Now, today we are going to discuss about what is population and what do we mean by population inversion. Now, to know about population inversion, first of all, you should know what is population. Population is nothing but that is the number of atoms. That is the number of atoms present in any state. Per unit volume. That is called population of that state. The number of atoms present per unit volume of a state is called population of that state. And at normal condition, the population of ground state is greater than population of excited state. At normal condition, the population of ground state is greater than population of excited state. Now, for the lasing action to emit laser light, population, the number of atoms in the excited state should be greater than number of atoms in the ground state. That means the population should be inverted for lasing action or to produce laser light. Now, if let us see on the screen, N1 is the number of atoms present in the ground state and N2 is the number of atoms present in the excited state. And here you see that at normal condition, the number of atoms present in ground state is greater than number of atoms in excited state. That is N1 is greater than N2. But if the atoms in ground state are pumped to the excited state by optical pumping, by electrical pumping, there are different methods by which the atoms in the ground state are pumped to the excited state, and that is called pumping. And while studying about laser, you know about pumping, and there are different types of pumping. One is optical pumping. When photon light interact with ground state photon, then the ground state atom absorb energy from the incident photon and they pump to the excited state. That is called optical pumping. लाइट को कारणले गर्दा यी एटमहरुलाई तिमीले एक्साइटेड स्टेटमा पुर्याइदियो भने के हुन्छ, त्यस्तोलाई ऑप्टिकल पम्पिङ भनिन्छ हो। अब यदि तिमीले इलेक्ट्रिसिटी पास गरेर यिनीहरुलाई चाहिँ एक्साइटेड स्टेटमा पुर्यायो, त्यस्तोलाई इलेक्ट्रिकल पम्पिङ भनिन्छ। भनेपछि पम्पिङ भनेको अरु केही होइन, ग्राउन्ड स्टेटमा भएका एटमहरुलाई एक्साइटेड स्टेटमा पुर्याउने प्रक्रिया हो के हैन। दैट इज द वे बाइ व्हिच द atoms in ground state are pumped to the excited state. Now, here we are assuming that N1 is the number of atoms present in ground state and N2 is the number of atoms present in excited state, and at normal condition N1 is greater than N2. Now, when photons are incident to the ground state atom, then what happens? Then they absorb energy. When they absorb energy, then they pump to the excited state. And a situation arises, a condition arrived at which the number of atoms in excited state, that is N2, becomes greater than number of atoms in ground state. And here, at this case, the population just inverted. In first case or in normal condition, the number of atoms in ground state is greater than that of excited state. But after excitation of the atoms in ground state, a condition arrived at which N2 is greater than N1. N2 is greater than N1. And such phenomenon is called population inversion. र यस्तो प्रक्रियालाई के भनिन्छ रहेछ, population inversion हुँदो रहेछ है त। र लेजर लाइट प्रोड्युस हुनको लागि, to produce laser light, population inversion is necessary. Population inversion is necessary to produce laser light. Now, this is about population inversion. Now, what are the types of laser? The different types, there are different types of laser, and in class 12 and in semester second semester, you have studied about the different types of laser. You study about ruby laser, you study about helium neon laser, and ruby laser is the example of solid state laser. Ruby laser is the example of solid state laser, and helium neon laser is the example of gas laser. And about ruby laser and helium neon laser, you have already studied in class 12 and in first year also. And another type of laser is semiconductor diode laser, and its example is gallium arsenide laser. Gallium arsenide laser. र तिमीले यो क्लासमा केवल सेमीकन्डक्टर डायोड लेजरको बारेमा मात्रै पढ्छौ. We discuss only the semiconductor diode laser at this class. Now, what is semiconductor diode laser? It is also called gallium arsenide laser. Now, by the word semiconductor diode laser, it is fabricated from p-n junction diode. So, a semiconductor diode laser is specially fabricated p-n junction device. p-n junction device, and that emits coherent light when it is at forward biased condition. And you know about p-n junction diode. And what is the forward biased condition? What condition is called forward biased condition? ल भन त यसमा फरवर्ड बायसिङ भनेको के हो भन त पीएन जंक्शनमा रमेश. रमेश परियार, फरवर्ड बायसिङ भनेको के हो भन त पीएन जंक्शन डायोडमा?
यदि डायोडको चाहिँ सर पीएन जंक्शन डायोडमा चाहिँ पी चाहिँ पोजिटिभ तिर जोडियो भने अनि एन चाहिँ नेगेटिभ हो भने चाहिँ फरवर्ड बायस.
ठीक छ, त्यो जान्नु पर्यो है त. ल, सो a semiconductor diode laser can emit coherent light when it is at forward biased condition. And the first semiconductor diode was first made by scientist R.N. Hall and his co-workers in 1962. In 1962, the first semiconductor laser was made by the scientist R.N. Hall and his co-worker. Now, what are the advantages of such type of laser? This laser has high efficiency, about 40%. Semiconductor diodes, the different advantages of semiconductor diode are it has high efficiency. It has high efficiency, about 40%, and its size is remarkably small, of the order of 0.1 millimeter long. It is very small in size. If the size is small, then it is very portable to use. It is very portable to use. अब सानो साइज छ भने प्रयोग गर्न पनि सजिलो हुन्छ, हो के हैन? हाई इफिसियन्सी रहेछ ड्यू टु स्मलर लेन्थ. इट इज भेरी पोर्टेबल इन युज्ड, and such type of laser can be operated at low temperature also. It can be operated at low temperature also. And this can also emit light almost anywhere in the spectrum from ultraviolet to infrared region. भनेको यसले अल्ट्राभायोलेट देखि इन्फ्रारेड सबै स्पेक्ट्रम सम्मको लाइट चाहिँ इमिट गर्न सक्छ. भन्नु भने अब सेमिकन्डक्टर डायोड एकदमै एडभान्टेजेस रहेछ. The advantages of semiconductor diode laser are it is small in size, so it is portable in used. That is first. Another is it has high efficiency, about 40%. Second, third, it can be operated at low temperature also. That is another advantage. And such type of laser can emit light almost anywhere in the spectrum from ultraviolet to infrared region. These are the advantages of semiconductor diode laser. And such type of laser was first made by scientist R.N. Hall and his co-workers in 1962. Now, this is the construction of semiconductor diode laser. Let us see on the screen. And by describing this figure, you can easily describe what is the construction of semiconductor diode laser. From this, here you see, this is gallium arsenide crystal. Gallium arsenide, it is a semiconductor. And this is very small in thickness. It has very smaller thickness of the order of 0.2 micrometer. म्युयम लेखेको छ हेर त, म्युयम माइक्रोमिटर. यो ग्यालियम आर्सेनाइड जुन क्रिस्टल छ नि, यो एकदमै यसको थिकनेस एकदमै कम छ, 0.2 म्युयम माइक्रोमिटर or माइक्रोन पनि भनिन्छ. That is also called micron. That is also called micron. So from this figure you can say a semiconductor diode laser is made up of an active layer of gallium arsenide, which is very small in thickness of the order of 0.2 micron or micrometer. And this crystal is sandwiched in between two types of semiconductor. One is P-type gallium arsenide aluminate and another is N-type gallium arsenide aluminate. हेर यहाँ यो स्मलर थिकनेसलाई तिमीले दुईटा, एउटा पी टाइप अर्को एन टाइप सेमिकन्डक्टर जुन ग्यालियम आर्सेनाइड एल्युमिनेटबाट बनेका छन् हो, यिनीहरूको बीचमा स्यान्डविच गरिया हुन्छ. दिस gallium arsenide crystal is sandwiched in between two types of semiconductor, and they are P-type gallium arsenide aluminate semiconductor and N-type gallium arsenide aluminate as shown in the figure. And here for the to produce laser light, resonant cavity or resonance should be produced or amplification should be occurred. Now for resonant cavity, the sides of the gallium arsenide crystal are polished. If they are polished, then multiple reflection occurs, and if multiple reflection occurs, then amplification takes place. So resonant cavity in such type of semiconductor diode laser is provided by polishing the opposite faces of the gallium arsenide crystal. And for the pumping action, you have the power supply. And with the help of power supply, you can pass the current. And if current is passed, then by electrical pumping, population inversion occurs. And this is about the construction of semiconductor diode laser. अब तिमीले यो फिगर हेर, वास्तवमा के रहेछ? A semiconductor diode laser is made up of an active layer of gallium arsenide, which is very thick, of the order of 0.2 micrometer, and this crystal is sandwiched in between two types of semiconductor. One is P-type gallium arsenide aluminate and another is N-type gallium arsenide aluminate, isn't it? And here to produce resonance or for amplification, the resonant cavity is provided by polishing the opposite faces of the crystal. When the opposite faces of the crystal are polished, then what happens? Then multiple reflection occurs, by which amplification occurs. And the pumping is done with the help of power supply. This is about the construction of gallium arsenide or semiconductor diode laser. Now, what is this working? How laser light can be produced from such type of laser? Now, for that, when current is passed through a PN junction diode in forward biased condition, I have already told you that this laser emits light in forward biased condition. So, to produce laser light, you should pass the current in forward biased condition. So when the current is passed through the PN junction diode in forward biased condition, then the excess number of holes from P region, they move towards the N region. Holes move from P region to N region. And what are the excess number of charge carrier in the N region? In N region, electrons are the majority charge carrier. So the electrons from N region, they move towards the P region, from N region, to P region. And during that time, they emit photon due to the transition of electron from conduction band to the valence band. When the electron jumps from conduction band to the valence band, then what happens? Then there will be emission of photon. Emission of photon, and which results, or this type of pumping results in the stimulated emission of radiation, and by stimulated emission of radiation, then laser light can be produced, and that light can be emerges out, or that can be intensified by increasing the current and decreasing the junction thickness. And if you decrease the junction thickness and if you increase the current through the PN junction diode, then you can intensify the current, you can intensify the light. And this is about the working of gallium arsenide laser or semiconductor diode laser. And from the system of gallium arsenide semiconductor laser, gallium arsenide semiconductor laser beam of wavelength which is ranges from 7000 angstrom to 30,000 angstrom. अब यो ग्यालियम आर्सेनाइड लेजरबाट अर्थात् यो सेमिकन्डक्टर डायोड लेजरबाट तिमीले 7000 एङ्स्ट्रमदेखि 30,000 एङ्स्ट्रमसम्म वेभलेन्थ भएको लेजर लाइट प्रोड्युस गर्न सक्छौ हैन। भनेपछि त्यति वाइड रेन्जको हैन, त्यति धेरै वाइड रेन्जको लेजर लाइटहरू तिमीले प्रोड्युस गर्न सक्दा रहेछौ। or from the system of gallium arsenide semiconductor laser beam of wavelength that ranges from 7000 angstrom to 30,000 angstrom can be produced. This is about construction and working of semiconductor diode laser. Now what is resonant cavity? Resonant cavity, अब resonant भनेको के हो त भन्दाखेरि एम्प्लिफिकेसन गर्नको लागि प्रयोग गरिने क्याभिटी हो, बुझ्नु बुझेन? A cavity in a laser due to which amplification of light occurs. किन भन्दा यो लेजर लाइट प्रोड्युस गर्नको लागि लाइट एम्प्लिफिकेसन हुनुपर्छ। तिमीलाई प्रिन्सिपल है LASER मा नि लाइट एम्प्लिफिकेसन बाई स्टिमुलेटेड इमिसन अफ रेडिएसन भनेको छ। भनेपछि रिजोनेन्ट क्याभिटी भनेको लेजर लाइट प्रोड्युस हुनको लागि त्यहाँ एम्प्लिफिकेसन हुनुपर्छ, र त्यो एम्प्लिफिकेसन गर्नको लागि हामीले जुन क्याभिटी प्रयोग गर्छौं त्यसलाई हामीले भन्छौं रिजोनेन्ट क्याभिटी। A cavity in a laser by which amplification of light occurs. A cavity in a laser by which or due to which or which helps for the amplification of light. Which helps for the amplification of light is called resonant cavity. And in case of ruby laser, there are two mirrors at the sides and multiple reflection occurs between the mirrors, and that helps for amplification. तिमीले रुबी लेजरमा पढाएको थियो नि, दुईटा छेउछेउमा दुईटा मिररहरु राखिया थियो। तब के हुन्थ्यो भन्दा जब फोटोन गएर मिररमा ठोकिन्छ तब फेरि रिफ्लेक्टेड हुन्छ, फेरि अर्को मिररमा आउँछ, रिफ्लेक्सन हुन्छ, भनेपछि मल्टिपल रिफ्लेक्सन अकर्स inside the tube by which laser light can be produced. That means amplification occurs. So in the case of ruby laser, light amplification occurs due to the mirrors, and the light beam is reflected several times. In mirror, due to which amplification occurs. And similarly, we have studied about semiconductor diode laser. And in gallium arsenide, how resonant cavity is provided? The resonant cavity is provided by polishing the opposite faces of gallium arsenide crystal. By polishing the opposite faces of gallium arsenide crystal, resonant cavity is provided there. So for laser, amplification is necessary. For amplification, to enhance or to produce amplification, a cavity is required, an arrangement is required, that is called resonant cavity. And for example, in the case of ruby laser, there are two mirrors and multiple reflection occurs between the mirrors by which amplification occurs. But in the case of gallium arsenide crystal, the opposite faces of the crystal are polished, and that provides the resonant cavity by which amplification occurs. In this way, resonant cavity is provided to produce laser light in different types of laser. This is about resonant cavity. Now The last topic in laser is application of laser. What are the different applications of laser? अब लेजरलाई तिमीले कुन कुन ठाउँमा प्रयोग गर्न सक्छौ त? There are large number of applications of laser in different fields of sciences in our daily life. There are different applications. Some applications are, यो पनि exam मा सोधेको छ है, write down some applications of laser. Discuss about semiconductor diode laser. Discuss about semiconductor diode laser and write down some applications of laser भनेर exam मा सोध्छ है त. त्यो सोध्यो भने अब यी 7-8 वटा मैले लेखिदिएको छु, कमसेकम 4-5 वटा याद गर है त. ल, they are used in surveying and ranging. They are used in surveying and ranging. Number 2, they are used to study the laws of interaction of atoms and molecules. Number 3, they are suitable for communication. They are used for communication. Number 4, they are used for welding, cutting of materials and drilling of holes. Number 5, they are used in eye surgery. They are used in eye surgery, treatment of dental decay, and skin diseases Number 6, they are used in holography. Number 7, they are used in printers, and they are also used in isotope separation. These are some applications of laser. अब यो त तिमीले प्र्याक्टिस गरेर याद गर्नु पर्यो है त. What is laser? Write down its applications. भन्यो भने चट्टै याद गर्ने है त. धेरै ठाउँमा प्रयोग गरिन्छ. अरु पनि एप्लिकेसन छ, मैले अब यति मात्रै लेखेँ है त. ल, यो भयो. अब यो भएपछि लेजर सिद्धियो है त. अब यो लेजर बाट धेरै क्वेशन आउन सक्ने भयो. 3-4 तरिकाबाट क्वेशन आउन सक्ने भयो है त. भन्दा लेजर टपिक मात्रै हो, तर यसमा पढ्नु पर्ने धेरै रहेछ है त. ल, अब लेजरबाट क्वेशन आयो भने गर्न सकिएला नि यमराज हैन?
सकिन्छ सर.
सकिन्छ नि हैन? गाह्रो छैन नि. यहाँ सुन, एकचोटी राम्रोसँग पढेनौ भने त आउँदैन. राम्रोसँग प्र्याक्टिस गर है, राम्रोसँग.
हुन्छ सर.
सकिन्छ त्यो. ल, ठिकै छ, प्र्याक्टिस गर्नु पर्यो. ल, अब यो पछि हामी फोटोग्राफी र होलोग्राफी पढ्यौं भने यो च्याप्टर चाहिँ सक्छौं है त. अब फोटोग्राफी भनेको के हो? अब यो त खासै धेरै अप्ठ्यारो कुरो परेन तिम्रो लागि. व्हाट इज फोटोग्राफी? फोटोग्राफी भनेको फोटो लिने प्रक्रिया हो के प्रोसेस हो. कुनै पनि वस्तुको हामीले 2 डाइमेन्सन, एउटा 3 डाइमेन्सनल अब्जेक्ट हुन्छ. इफ यु हैव 3 डाइमेन्सनल अब्जेक्ट and if you take the image which is 2 dimensional, object is 3 dimensional but the image is 2 dimensional, then the process is called photography. The process is called photography. So what is photography? Photography is the process of, it is the process of forming a permanent record of an image on a specially treated film or paper, which is called photography. And in photography, we take 2-dimensional image. We take 2-dimensional image of 3-dimensional object. अब तिमीले एउटा पेपरमा फोटो बनाउँछौ नि, वास्तवमा अब्जेक्ट 3 डाइमेन्सनल हुन्छ, तर तिमीले एउटा प्लेनमा, एउटा पेपरमा त्यसको चाहिँ इमेज बनाउँछौ. त्यो पर्मानेन्ट रेकर्ड हुन्छ. दैट इज पर्मानेन्ट रेकर्ड अफ द इमेज. That is a permanent record of the image. And by this process, a 2-dimensional image of a 3-dimensional object is formed in a photographic film. And during photographic process, there are 2 steps. In first step, we make a negative of the object by developing the film, and then its positive is obtained through the printing. पहिला त्यसको नेगेटिभ बनाइन्छ हैन, त्यसपछि त्यसलाई प्रिन्ट गरेर के गरिन्छ, पोजिटिभ बनाइन्छ. भनेपछि फोटो लिइन्छ. भनेपछि दुईटा स्टेप रहेछ. फर्स्ट अफ अल यु शुड टेक अ नेगेटिभ बाय डेभलपिङ द फिल्म, एन्ड देन अ पोजिटिभ इज obtained through the printing. And the negative is a 2-dimensional record of intensity of light received from the object. अब यहाँ फोटो खिच्दाखेरि के हुन्छ भन्दा अब्जेक्टबाट लाइट आउँछ र त्यसबाट के हुन्छ, त्यसको लाइटको इन्टेन्सिटी एब्जर्भ गरिन्छ. ओके, सो यु क्यान से ड्युरिङ द फोटोग्राफिक प्रोसेस, that is the record of light intensity which is received from the object. So in case of photography, it contains the information about the square of amplitude, because you know the intensity of light is directly proportional to square of amplitude. The intensity of light is directly proportional to square of amplitude. So in photographic process, it gives only the information about square of the amplitude, and in this case the information about the phase is lost. The information about the phase दुईटा हुन्छ जब लाइट आउँछ नि हो, लाइट आएपछि त्यहाँ लाइटको इन्टेन्सिटी र अर्को फेज भन्ने कुरालाई मतलबै गर्दैन भनेपछि द इन्फर्मेसन अबाउट फेज इज लस्ट इन द केस अफ फोटोग्राफी, एन्ड द्याट इज द मेजर डिफरेन्स बिट्विन फोटोग्राफी एन्ड होलोग्राफी. होलोग्राफीमा फेज पनि कन्सिडर गरिन्छ भने फोटोग्राफीमा फेजको कुरा गरिन्छ केवल इन्टेन्सिटी, लाइटको इन्टेन्सिटी विच इज डाइरेक्टली प्रोपोर्सनल टु स्क्वायर अफ एम्प्लिट्युड, यति मात्रै ख्याल गरिन्छ भने यस्तो प्रोसेसलाई हामी भन्छौँ photography. And there are 4 steps in photography. One is exposure, another is developing, another is fixing, and last one is printing. There are 4 steps in photography. They are exposure, developing, fixing, and printing. And to take photo, we use an instrument. To take a photo of an object, we shoot an instrument, and that instrument is called photographic camera. That is called photographic camera. And here we are discussing about basically a lens camera, and which consists of light-proof base. Light-proof base. भनेको त्यहाँबाट त्यो बेसबाट लाइट जाँदैन भने हैन, with a lens system at the front. This is the lens system at the front. At the front. And this lens system acts as converging lens. That lens system acts as converging lens, and light from the object is focused on the film F by the lens system, and there is a shutter between the lens and the film. This is the shutter. This is the shutter between the lens system and the film, as shown in the figure. This is about the construction of photographic, simple construction of photographic camera. And to take photo, a photo कसरी लिन्छ त भन्दाखेरि हेर्दा, to take a photograph of an object, the shutter is opened and closed very rapidly. लामो एक्सपोजर गर्ने होइन, बुझ्दैन? त्यो सटर भनेको के हो भन्दा कुनै चीज इन्ट्री गर्नको लागि राखिएको चीज हो, त्यसकारण लाइट इन्टर गर्ने भनेको सटरबाट हो, र त्यो सटर धेरै समयसम्म ओपन राखिदियो भने के हुन्छ भन्दा लाइट लामो समयसम्म एक्सपोज हुन्छ र त्यसले फोटोग्राफी फिल्मलाई बिगार्छ, हो कि हैन? भनेपछि यहाँ हेर त इम्पोर्टेन्ट थिङ, टु टेक अ फोटोग्राफ द सटर इज ओपन एन्ड क्लोज्ड very rapidly so that only desired amount of light enters the camera after reflection from the object. अब इमेज लिने भनेको त के हो भन्दा अब्जेक्टबाट आएको रेहरूबाट हेर्ने हो. The image of the object is formed by 2 ways. One is either the rays of light that are reflected from the rays actually meet at a point so that real image is formed. Otherwise, if the ray of light appear to meet after reflection from the object mirror, then virtual image of the object is formed. So after reflection from the object and the film is exposed to the light for a very short time, and an arrangement fitted in the camera can move the lens forward and backward to give a sharp picture of the object through the lens. There is an arrangement which is fitted on the camera to take the sharp picture of the object, and that can move forward and backward. And the image produced by the lens system has to be bright enough. The image produced by the lens system has to be bright enough. सकेसम्म त bright हुनै पर्यो. So that during a very short time of exposure, a sharp image of the object is formed on the film. A sharp image of the object is formed on the film, and the brightness and sharpness of the image depends on diameter of the aperture. The sharpness and brightness of the image depends on diameter of the aperture, which is the circular opening through which light passes, and the amount of light falling on the film. The amount of light falling on the film is controlled by the aperture, while the image the while the area of the image on the film is controlled by the focal length of the lens. With the help of focal length of the lens, you can control the area of the image on the film. The area on the image on the film can be controlled by the focal length of the lens, while the amount of light falling on the film is controlled by the aperture. Aperture is a small opening. Okay, small opening. And this is about photography. So photography is the process. In short, photography is the process by which a two-dimensional image of the three-dimensional object is formed on a photographic film, or it is a permanent record of an object, of an image. It is a permanent record of an object. And to take photo, we use photographic camera. And there are 4 steps. They are, what are the 4 steps in photography? The 4 steps in photography are exposure, developing, fixing, and printing. And in the case of photography, only the intensity of light is considered. And about the information of light, this information is lost while taking photograph of an object. And this is the major difference between holography and photography. In holography, we also consider the phase variation also. Information about the phase also. But about the information about the phase is lost in the case of photography. This is about photography प्रोसेस. अब लास्टमा एउटा छ यो होलोग्राफी अर्को क्लासमा पढाउँछु है त. अब टाइम पनि अलि सिद्धिएछ है त. यो अर्को क्लासमा पढाउँला. अब यो पछि अनि हाम्रो यो च्याप्टर पनि सिद्धिन्छ है त. 3-4 वटा कुराहरू लगभग 3टा. यहाँ सुन, लगभग अब हामी 1 पिरियड पढ्यौँ भने कहिलेकाहीँ 3 वटा नत्र कहिलेकाहीँ 4 वटा क्वेसन सोध्छ नि यसबाट है त. सुन्यौ?
ओके सर.
ल यो राम्रोसँग पढ. अब लास्टमा म भोलि अर्को क्लासमा तिमीलाई होलोग्राफीको बारेमा सामान्य डिस्कसन गराउँछु अनि त्यो पछि यो च्याप्टर सकिन्छ है त.
हुन्छ सर.
ल थ्यांक यू अल. थ्यांक यू अल एन्ड गुड बाई.
थ्यांक यू सर.
बाय बाय सर.
बाय बाय.
थ्यांक यू सर.
बाय.
थ्यांक यू सर.
वेलकम अल.
मिसिङ सर.
रेकर्डिङ नै अफ गर्नुभयो नि सर.